1.
So we did our Indie Lab on, we wanted to determine what breaks paper, momentum or energy. So, yeah. That was our purpose. We wanted to determine whether it's momentum or energy that affects the paper breaking, like when you drop an object on paper. And I predicted that they would both have equal effect, and Colin said...
predicted that the kinetic energy would have a greater effect since velocity has a greater effect on kinetic energy than momentum. And can I go over here?
Please, go wherever you like.
So we used little mini encyclopedias like this, and we built this like cavern that we taped the paper over, so there would be room for the object to fall through. And so we just like taped those down and made sure they were tight. And we did it on the table at first, but then later on we realized we had to do it on the floor because we needed even a higher drop height. So and then we used a baseball and a golf ball, and kind of by chance the baseball weighed, it was 3 times as massive as the golf ball. It was like 3.05. The ratio of the masses, so we got kind of lucky. So we just, to make it easy, we just made the heights. When we did it later, we made the heights like factors of 3. So, and then yeah, so we just dropped the baseball on the paper, and the.
All right, so to figure out how high, like the trick was to figure out how to keep momentum constant while changing energy, and to keep energy constant while changing momentum, because they both rely on the same things, momentum or mass and velocity. So we played with the ratios of the masses and just mi-i's, mi-f, and so to keep momentum constant, we use, like, one was a factor of 3 and the other was a factor of 9 because of the equations. So then we took a video of each drop and did video analysis to find the final velocity right before it hit the paper. And then we measured the drop height and measured whether it broke or not. And it turned out that what we were trying to keep constant didn't really stay constant due to our error. I mean, there's a lot of things that could go wrong, I guess, in this, because we're dealing with so little numbers. So that kind of threw off our conclusion because we weren't able to come to a conclusion using our data. But one thing we did notice that was kind of cool was that the 4 times the paper didn't break. So it only broke, it broke every time except for 4, and that was when, it was only with the baseball, and those were the 4 lowest velocities of all of our runs. So.
And we had a little bit of like some strange data, because like at some points like we dropped the golf ball from one height and broke the paper, but then we went higher and it didn't break for some reason. So there's some weird things going on, so we had to work around that.
Yeah.
So I don't know what was happening.
We had to take a lot of trials.
Yeah.
When that you just described happened, did you do that again?
No. We were just really frustrated. And like made it even higher.
That flies in the face of like momentum or energy being responsible for breaking paper.
Yeah.
Oh my goodness. Questions?
Yeah.
I have a question if Robbie doesn't have one.
Wait,
Robbie certainly has a question. All right, Rashawn.
Do you think that it didn't, like when those times that the paper didn't break and you like increased the height and it still didn't break, do you think that has to do with like maybe the strength of the paper, like it was different?
Yeah, like there were some, because it wasn't, like we noticed that if we didn't get the, where's our setup? So if we didn't get like this part perfect and really tight, then when we dropped it, there'd be give here from the books.
And sometimes they
So it-
slid in.
Yeah, so we had to make sure that, like if we saw that that happened and the paper didn't break, we would throw that out and then retake it. And that may have, that probably what was causing the weird data when it would break from here but not break from
Or if it like landed closer to the books, the paper was probably stronger at those points, like near the edge of the books instead of like the direct center. So dropping it from those big heights, it could have like not been in the exact middle.
Did you notice or take into account the issue that the pressure on the paper would be different depending on the area of the ball that contacts it? I was thinking about a baseball versus a golf ball.
That was my question.
They're,
My hand was raised and you wrong to that was the question.
oh shucks. So back to Sabrina's question.
In our data, we didn't really think about that or take that into account, but I think we did talk about it in our conclusion of our write-up.
Okay, I'll look at it there.
Wouldn't, because it's a sphere, wouldn't it still only be 1 point that,
Do you believe that just a single point might contact the paper?
Well, when it hits it, when the paper kind of like
Give
give
at first.
and like wrap around the ball, so it would be more.
Yeah. In an ideal circumstance, I agree with you, Jack. But in a real circumstance, the paper's going to give a little bit before it begins to tear or not tear, before it makes that decision. Cool. Thanks, guys.